So welcome to this presentation. As you can see, the title is the climate change. So I'm Joël, I'm French, and I'm a volunteer here at Arrocha. So just before we start, Arrocha, probably most of you know, it's a Christian organization, and we're working for the conservation of the environment. We don't really have climate change activities, especially targeting climate change, but we want to raise awareness on this subject. Mostly, so the reason why we do this is because as a Christian organization, our focus is to care for God's creation, and we want to involve as many people as possible in this act of honoring God, our Father and our Creator. And we also believe that tackling environmental issues requires joint efforts in action and a common sense of responsibility. So that's why we do this. You can put the next slide. This presentation, it's the first of a series of 4. The first part is unveiling the science today. Second part will be rethinking agriculture next week. Then mobility for tomorrow in 2 weeks. And finally, another look at energy on June the 5th. And in the afternoon, it will be followed by a workshop, still on the subject of climate change. It was specifically designed to talk to people who are not very familiar with environmental concerns. So if you are around, or if you know people who would be interested in participating in this workshop, feel free to invite them, because that's the point. And we can have up to 30 people participating, so. So, part 1, our Earth, climate, and the way it is changing. An overview of its original functioning, the disturbance it faces, and their consequences. I just want to say before we start that I am not an expert. I'm not a climatologist. I'm just a volunteer. I've studied sustainable development, but even if I have general knowledge on it, I'm not an expert. So the goal here, especially when I prepared this presentation, I try to remain as fact-based and to keep an approach based on science mostly, so that it's not political, it's not a matter of point of view, especially not mine, because I'm not relevant. I would not be. So first, the summary first. First part will be the functioning of our world's climate, then the carbon cycle and its disturbances, then the effects climate change could have on our planet and on our societies, and finally, a conclusion. So the climate, the definition of the climate is a statistical description of the weather in terms of averages and variability for long periods of time. It's quite important to know that, because some people might confuse it with meteorology. And meteorology only is about short-term predictions. And so why I say it's important is because sometimes it can be tempting to just look at the weather and think, to draw a conclusion out of the weather, but a weather doesn't mean anything in itself, because climatology is looking at periods of time, at least at the very least of a month, but it's also going up to 30 years. Most of the time with the averages, it's on 30 years periods. Okay, so the functioning of our world's climate. As you all know, the Earth is getting energy from the sun. It's actually the main source of energy. We're getting, there is about 340 watts per square meter that are contacting the Earth atmosphere, but there is only about half of it that the Earth receives. The other half is either reflected into space. You can put, yeah. There's about 30% reflected back into space, and 20% that is staying in the upper layers of the atmosphere, so we can feel it down here. Now, every object, whether it's a pencil, your human body, or the Earth, every object is emitting a thermal radiation, what we call thermal radiation. And this radiation is depending on the temperature of the body. So the higher you are and the more thermal radiation you are emitting. Think of it like a stone wall in the summer that stays all day long in the sun, and then at night, even when the sun is down, you can feel this heat. That's thermal radiation. It's infrared light. So the Earth is getting ultraviolet light from the sun, and it's transforming it into thermal radiation that is going in the direction of space. So it means there are two energy flows. Now, can somebody guess what's happening if there is more energy coming in than coming out? Yeah, it's getting warmer. And on the other side, if there is more energy coming out than coming in, it's getting colder. On the long term, those two energy flows, they even out, but they can vary. And they vary for different reasons. One of the reasons can be just the way the Earth rotates around the sun, because sometimes it's closer or further from the sun, so the temperatures can vary. It can also be because of solar eruptions, but it can also be because of a third factor that we will see right now. So the Earth is a complex system that is working thanks to many natural cycles. The main ones are the energy cycle, but we can also think about the water cycle. And a third one that is very important, as important as the others actually, even though we don't see it, it's invisible, it's the carbon cycle. Now, why carbon is important? Because it's forming the atoms of CO2 and CH4 that are one of the main greenhouse gases. So, do you know what's a greenhouse gas? That's a tough question. It's a word we hear a lot of times, but to describe it precisely, it's quite technical, yes. So, a greenhouse gas is a gas that has the ability to absorb a part of the thermal radiation I talked about before from the Earth and return it to the Earth's surface. So, those greenhouse gases are like a blanket in the atmosphere that is preventing this thermal radiation from going straight back to space. So instead, you can show the next slide. This is pretty much what it looks like. It looks complicated, but if we want to just make it simple, here we have the sun rays touching the Earth. There is already a part of it that is sent back into space because of the clouds, for instance. And then when it reaches the Earth's surface, it heats the Earth, and then it's sent back to space. But here we have greenhouse gases, in which we can find water vapor, CO2, methane, and other gases, and they are stopping this thermal radiation from going back into the atmosphere. Now, it's important to note that those greenhouse gases, they are important. We need them. Do you know what would be the temperature of the Earth on average throughout the year if there were no greenhouse gases at all?
-20?
-18.
To some gelée.
Yes, -18.
Yeah.
Exactly.
1-0, but
So on average, so it means it would be very, very cold. Actually, it would be impossible for us to live here. It would be basically ice everywhere. So we need them. So here in the first part, we have understood more about the energy coming in from the sun, about the greenhouse gases, and now we'll see the carbon cycle, how it works, and its disturbances. This is a graph that shows the variations of the temperature on Earth across the last 2 million years. You can see it's always fluctuating. That is normal on the long term. Now, second part, the carbon cycle and its disturbances. So the carbon is a very abundant molecule on Earth, and most of it is stored in rocks, but it can be stored in actually many, many things, as we see on this graph. So carbon is basically everywhere. It's in the atmosphere, it's in the ocean, it's in the plants, it's in the soil, but mostly it's in the rocks, in the layers underground of the Earth. But it can move through all of these reservoirs. It can move on the short term and on the long term. There are actually we differentiate two types of carbon cycle. There's the slow one and the fast one. I'll give you an example of the slow carbon cycle. So the carbon from the atmosphere combines with water to form a weak acid that falls to the surface in rain. You can show the next one. The acid slowly dissolves the rocks and releases different ions that are then carried to the ocean. And in the ocean, the calcium ions combine with bicarbonate ions to form calcium carbonate. And it's quite technical, but calcium carbonate is basically the chalky white substance you find on your faucet. And in the modern ocean, most of the calcium carbonate is made by shell-building organisms and plankton as well. And after those organisms die, they sink to the seafloor, and over time, the layers of shells and sediment are cemented together and turned to rock, storing the carbon in stone and limestone. So that's an example of the slow carbon cycle, and it takes a lot of time, really a lot of time. But it's one process that is making possible the fact of removing carbon from the atmosphere and putting it into the rocks. It's those layers of sediment and shells. Now, another example is the fast carbon cycle. And so this is an example of fast carbon cycle. It's basically you have carbon in the atmosphere. The trees, but here they show trees, but it's basically any plant. Actually, you could replace this with meadows or even coastal like coral and plants. They store carbon when they grow, and when they die, either because there is a fire or just because they die, they decompose and they release all the carbons they stored when they were growing. So it's a cycle, and we call it a short cycle because it's happening on a much shorter scale than the one before. So from a technical point of view, plants and plankton take CO2 from the air by absorbing it into their cells, and using energy from the sun, they combine CO2 and water to form sugar and oxygen. You can show the next slide. It looks like that. It looks complicated, but it's actually just carbon dioxide plus water plus energy are transformed by plants in sugar and oxygen. And sugar is what makes them grow. So the fast carbon cycle is so tightly tied to plant life that the growing season can be seen by the way carbon dioxide fluctuates in the atmosphere. So you can show the next slide. Yep. In the northern hemisphere winter, when few plants are growing and many are decaying, atmospheric CO2 concentrations climb. But during spring, when plants begin growing again, concentrations drop. Okay, now, next slide. What could disturb this cycle, in your opinion?
Pass.
Okay, but from a more technical point of view.
For example, chopping down trees will release more CO2 quicker, so disrupt the short-term carbon cycle.
Yeah.
Or increases in temperature will increase the acidity of the ocean and therefore decompose the rocks and all the marine organisms.
So basically taking carbon from one reservoir to another, in a simple way. Yes. That's the example. And how do we do that? Because, yeah, how do we do that? Do you have an answer?
Fossil fuels?
Burning fossil fuels,
Yeah.
basically, yeah. Yeah. Isn't that pretty? Looks nice, right? Do you know, could you name the fossil fuels?
What?
How many fossil fuels are there?
Coal.
Yeah.
There's coal, yes.
Oil.
Oil, yeah. And
Yeah.
gas. Three. Coal, oil, and gas. So those fossil fuels, it's important to realize that we use them for everything. The obvious answer would be fueling your car to move, so transportation, but it's also used for heating, like you can see here, or for even growing plants, because nowadays most fertilizers are chemically produced. Now, third part, the effects this climate change could have on the ecosystems and on our societies. There are lots of different effects this could have. This is already having, by the way. So the first one, the obvious one, is temperatures of the atmosphere rising because there is more carbon dioxide, more greenhouse gases in the atmosphere, so more greenhouse effect. Also, it's important to note that temperatures are, when we say temperatures are rising, it's an average on the world throughout the years, but it's actually rising more at the poles than along the equator. Yes. Yeah. Second one is melting of the ice sheets, glaciers, and sea ice. We can also say, next one, water temperatures rising, disruption of the water cycle, sea level rise. By the way, do you know why the sea level is rising? Okay, that's
And one more.
that's partly true.
And also water getting like
Yes.
bigger because
So,
of
that's one part. Because the water temperatures are rising, hot water basically it's expanding. It takes more space than cold water. So that's one reason. And the second reason is not exactly ice melting, because glaciers and sea ice, ice sheets and glaciers are melting, and so they're putting more not salty water in the ocean. But sea ice is not provoking the sea level rise. Do you know why? It's because sea ice is already in water. So ice sheets are ice or snow on top of land. So they are not inside water. But sea ice is already, it's like an iceberg. And I don't know if you've ever noticed, but if you're in summer and you put an ice cube in your glass, it will never overflow. Because it takes the same space, whether it's an ice cube in water or melted water.
Archimedes theory.
Hmm?
Archimedes
Yeah.
theory.
Exactly. So sea ice is not taking more space, it's not making the sea level rise. But the glacier, the ice sheets, yes. Other impact is the acidification of the ocean. And is there another one? No. And all of these things, they have impacts on our societies and on humanity and the environment. Those impacts are threats to terrestrial biodiversity, threats to marine biodiversity, heat waves and droughts, displacement of vectors of diseases, hurricanes, floods, fires, water scarcity, and decline in agricultural yields.
I have a question.
Yes.
What else we scarcity?
Lack of water. When something's scarce, there isn't a lot of it.
Partir, manque de... Yeah, it's not really a pretty picture. I know. But I think it's important to be aware of what we are risking by not acting and not tackling environmental climate change. So yes, in conclusion, we have understood together how the solar and the earth are exchanging energy. We have seen what the greenhouse gas and the greenhouse effect and how it works as a blanket over the earth. We have also seen that the responsibles are fossil fuels, namely coal, oil and gas. And we have seen the impacts of them. I don't want to bring solutions right now to this issue because that's basically what we are going to do in the next presentations, the next 3 ones. But yeah, I think this is the first, yes, this is the sources. This presentation was the basis for the next 3 ones, so I encourage you to come for the next 3 ones, where we'll speak more about the solutions. But yeah, I hope you enjoyed it, and thank you for your attention.